Hello everyone, welcome to day 9 of 15 days of DAX. Today we are going to explore time intelligence functions in DAX. These functions help analyze data over time, making them essential for trend analysis, year-over-year comparisons, and cumulative calculations in Power BI. We are going to see some interesting functions today like TOTALYTD, same period last year, parallel period, DATEADD, DATESYTD, and at the end we will see a challenge for day 9 so that you can understand how to implement these functions in Power BI for practical use cases. The first function we are going to see is TOTALYTD. Actually, in order to understand TOTALYTD, we need to look at DATESYTD first. So let's go to DATESYTD function and try to understand what this function is. So DATESYTD function returns a set of dates in the year up to the last date visible in the filter context. Don't worry if you do not understand this yet, because we are going to see this in detail and I will explain how this function works. The use case of this function is to retrieve all dates for the current year's YTD calculations. The DATESYTD function returns a dynamic range for YTD calculations and it works well inside calculate for custom aggregations. It is used internally by TOTALYTD. This is the reason why we are considering DATESYTD before TOTALYTD, because TOTALYTD is internally using DATESYTD. Now let's see DATESYTD function in detail. DATESYTD function returns the dates from the 1st of January of the currently selected date. Here we are using calculate table and inside we are using DATESYTD, and you can see that the date that is specified is 2007 May 12th. So according to DATESYTD, we should get all the dates starting from January 1st. So the output of this function is a single column table with dates starting from January 1st till the maximum date that it finds in the context, which is 12th May. So this is how DATESYTD function works. If the selection contains larger periods, it returns YTD using the end of the entire period. So this is the key point when you use DATESYTD function. Here we are taking the period starting from February 5th and ending at 12th May. So how does DATESYTD implements this function? It will find the maximum date in the context, which is 12th May in this case, and it will give the result starting from January 1st. So even though you can see that the starting date which we have mentioned in the context is 5th February, the output of the DATESYTD function is still the table starting from January 1st till the maximum date it finds. This is the key point to consider for DATESYTD function. So the output of both of these functions will be this table starting from January 1st and it will end at 2007 5/12. So this is about DATESYTD function. Now let's go back and see how TOTALYTD function works. TOTALYTD function calculates the year-to-date total for a measure. It evaluates the specified expression over the interval which begins on the first day of the year and ends with the last date in the specified date column after applying specified filters. So this is the syntax for TOTALYTD, in which we pass an expression which we want to calculate, and after that we will specify the dates and with additional filters if we want, and the filter and year-end dates are optional. The use case of this function is to calculate the total sales from the beginning of the year to the selected date. So Let's see how we can calculate the total sales YTD. So inside total sales YTD, we need to pass the expression that we want to calculate. So in this case, it is sum of sales amount, and after that we pass the date column. So this will calculate the year to date sales based on the dates available in the sales date column. The total YTD function aggregates values from the beginning of the year up to the selected date. It requires a valid date column to perform accurate calculations, and it works best with a continuous and properly formatted date table with no gaps. So this is the prerequisite for any time intelligence function. It should have a properly formatted date table with no gaps. Now let's see the total YTD function in detail. So we are taking total YTD example here. This example shows the sales in the current and both the quarter to date and year to date sales. Here we are creating a measure for sales QTD. For sales QTD, we are calculating the sales amount. This sales amount is a measure which is sum of sales amount. So this is a measure and we need the quarter to date value of this sales amount. So we are using dates QTD here in order to get the quarter to date sales amount. The next measure we are using is sales YTD, which is using dates YTD, which we have seen in the previous example, and we are using summarize columns in order to create this table. This table contains calendar year month number, calendar year month, sales amount, which is the measure, sales QTD, which is the measure calculated here, and sales YTD, which is the second measure that we have created here. So here we can clearly see how these functions actually work. We have months for each year and we have sales amount for each month, and let's try to understand how sales QTD calculates the sales amount based on quarter to date. In the first row you can see the sales amount is same as the first month. So for January you can see the sales QTD is same as sales amount. Let's try to understand for first quarter. So the first quarter includes 3 months, January, February and March. Now let's see how it calculates for February. For February, the sales QTD is sum of January and February. So this will add the 2 months total for sales amount. And similarly for March, it will be sum of first 3 months. When we go to April, this will be the start of second quarter. So sales QTD will start from the beginning of the second quarter, which is April. So this will be same as sales amount for April because that is the first month in the second quarter. Now for second month in second quarter, it will be sum of April and May, and for third month it will be sum of April, May and June. So this is how the sales QTD is calculated, and I hope you understood how dates QTD is taking the dates in order to do the calculation for sales amount. Now let's try to see how sales YTD works. Sales YTD will add up all the details starting from January of current year. So this is what is happening here. So for January it is sum of January month, for February it is sum of January and February, and for March it will be sum of first 3 months, for April it will be sum of first 4 months, and it will continue until it reaches the end of the current year. And when we go to new year, which is 2008, it will start from the beginning of that year and it will add until it reaches the end of the date in that table. So this is how sales YTD works. So this is using dates YTD function. Now we are going to see how we can use total YTD instead of dates YTD. So both of these DAX formulas will give the same result. In the first example, we are using DATESYTD and DATESYTD. So whenever you use DATESYTD in order to do any calculation, you will be using calculate function in order to change the context for the date by using DATESYTD function. So here we are calculating the sales amount using DATESYTD as our context. So what we can do is, instead of calculate and DATESYTD, we can use TOTALYTD function in order to do the same calculation. So for TOTALYTD, we can use the sales amount, which is a measure that we have created, and we need to specify the date, and this will give exactly the same result as sales YTD, which we have seen previously. And we can perform the same operation of calculate and DATESYTD by using total QTD here. So total QTD will give the same result as using calculate and DATESYTD, which we have seen previously. So this is how total YTD function works, which is basically the implementation of using calculate and DATESYTD function. Next we are going to see another interesting DAX function, which is same period last year. Same period last year returns a table of dates from the same period in the previous year. The use case of this function is to compare this year's sales with the same period last year. So if you want to get the last year sales, you can use calculate and sum of sales amount, and you can use same period last year and you can specify the date. So this will give the details of sales amount for the last year. The same period last year function shifts the date range by exactly 1 year, and it works well for calculating year-over-year comparisons. And what's interesting about this function is it supports day, month, and quarter comparisons. So for example, if you have a table visual with days, you can get the last year's corresponding sales amount for each day using the measure that you have created using same period last year. Similarly, if you have month in your table visual, it will dynamically calculate the sales amount for the last year if you use that measure, and similarly for quarters as well. So same period last year returns the selected period shifted back 1 year. And one more point I would like to mention here is it respects the granularity. Granularity means the level of detail. For example, if we want to get the data based on days, we can get the data based on days, we can get based on months, and we can get based on quarters. So here we are taking the start date and end date, and we want to shift these dates by 1 year. So we are using same period last year, and we are specifying the start date and end date, and this will give the result like this, which is shifted by 1 year for each of the dates that we have specified. So internally, same period last year corresponds to the call of DATEADD function, which we are going to see later. But DATEADD function syntax is this, in which we need to specify the dates, the offset, and the year. So here -1 means we want to shift the year back by 1 year. Like I said, same period last year's implementation is internally doing DATEADD. So you can see that this is equivalent to using this function where we specify the DATEADD function with an offset of -1 and year as the interval, and specifying the start date and end date. So both of these functions will produce the same result. So now imagine you want to calculate the sales amount, then the implementation of this function is as shown here. So we will take the start date and end date. First we need to specify the sales amount and the same period last year function and specify the date column. And in order to give this date column the context which should take the start date and end date, we need to specify the start date and end date here outside this calculate function. So it starts at the given start date and end date, and it will calculate the sales amount, and it will give us the sales amount for the given for the same period last year, which is starting from 2007 January 1st to January 31st, because we have given the start date as January 1st 2008 and end date as January 31st 2008. So it will give the same period last year, which is this range. So this is how same period last year function works. Now let's move to the next function. Parallel period shifts the date range forward or backward by a specified number of periods. This function takes the current set of dates in the column specified by dates, shifts the first date and the last date, the specified number of intervals, and then returns all contiguous dates between the two shifted dates. If the interval is a partial range of month, quarter, or year, then any partial months in the result are also filled out to complete the entire range. This is the syntax for parallel period function, in which we need to pass the dates, the number of intervals, which is basically the offset, and the interval. Interval can be day, month, year. The use case is to compare the sales from the previous month. So here we are calculating the sum of sales amount for the previous month. So we will use parallel period in order to shift the date back by 1 month. The parallel period function shifts the date context by a defined interval like days, months, quarters, or years, and it is useful for period over period comparisons, and it returns the full shifted period, not just matching dates. So this is a key difference between the same period last year and parallel period. Same period last year will respect the granularity that we specify, whereas parallel period will give the entire full shifted period, not just matching dates. So if you do not understand this yet, we are going to see this in detail now. So let's see how parallel period function works in detail. So parallel period returns a full period shifted in time. For example, if we want to shift a given date, we are giving the date as 2008 8/15. If we specify parallel period date offset as -1 and interval as year, then we get the result starting from January 1st of previous year, which is 2007, and it will continue throughout the entire year. So this range ends at 2008 12/31. A common usage of parallel period is to use 0 for the offset. What happens when we specify 0 here? When we specify 0, it means we do not want to move back in time or forward in time. So basically it will give the entire range in the current context. So here we are specifying 2008 August 15th, and we get the full range of given date, and the interval here is month, so we get the full month range starting from 1st of August and ending till the end of this month. In this example, we are taking the starting period as 15th August to 20 September. So internally, the parallel period function will produce the entire period for the given period. So the entire period for the given period is 1st of August till 30 September. It will shift the period based on given offset and given interval. So here the offset is +1. So for August next month is September, and for September next month is October, and this will give the output starting from September 1st ending at October 31st. So let's see a real life example how we can use parallel period in order to calculate the sales amount. This report shows the result of sales in current month. current quarter and previous quarter. So we are calculating a couple of measures. The first measure will calculate the current quarter. So in order to calculate the current quarter, we are giving the offset as 0 and interval as quarter. So this will give the entire quarter range for the given date, and it will calculate the sales amount based on the current quarter. Next measure is about previous quarter. So in order to get previous quarter, the offset is -1 and interval is quarter. So this will give the sales amount for previous quarter. And at the end we are using calculate table in order to create the table, and inside that we are using add columns and summarize in order to get the data based on year, month and month number. And after that we are taking sales amount in order to get current sales quarter, which is the measure that we have created here, and sales previous quarter, which is second measure. And for calculate table we are giving the context as current year 2007 and month number less than or equal to 9. So all of this calculation is based on given year and given month number. So you can see that the months we have are starting from January till September, and these are the current sales amounts, which is the sales amount measure. Now let's see how current quarter sales is calculated using parallel period function. So current quarter sales will be the sum of first 3 months. So it should be the sum of these 3 values. So you can see the current quarter sales here. So it's clear that how current quarter sales is calculated. Now let's see the previous quarter sales. For previous quarter sales, since we do not have any previous quarter, for first quarter it will be blank. For next quarter it will get the previous quarter sales, which is this value, and for next quarter it will get the previous quarter sales, which is this value. So this is how parallel period can be useful in order to get the quarter sales. Now let's see DATEADD function, which is one more interesting and most common function. It shifts the date context forward or backward by a specified interval. The use case is to analyze sales performance from 30 days ago. So if we want to get the sales amount 30 days ago, we can shift the date using DATEADD, and we can specify the offset as -30, and we can specify the interval as day, and this will give the sales amount 30 days ago. The DATEADD function works like parallel period but preserves granularity. So this is the key difference between DATEADD function and parallel period function. The DATEADD function will not give the entire range like parallel period does. It will give whatever we need. So that is the main difference between DATEADD and parallel period. It supports both positive and negative shifts, and it is more flexible for dynamic date calculations. So the DATEADD function is the generic function. It shifts a period back and forth over time using day, month, quarter and year. This example produces the same result which we have already seen regarding same period last year. So instead of same period last year, we can use DATEADD function here by specifying year as interval and offset as -1, and this will produce this result. So you can see that it is not giving entire range, it just gives what we have specified. So we have specified the starting date and ending date, and it will give the range only for the given dates. And what's interesting about DATEADD function is it has quite complex logic to move months and quarters the right way, handling months with different dates. So in this example we have start date and end date for February month, and we know that February has either 28 or 29 based on leap year, based on whether the year is leap year or not. So the DATEADD function will automatically identify the end of the month, and it will give the corresponding end of the month by shifting to the next month in this case. So in this case, it identifies that 29 is the last day of February, and it will give the corresponding last day of next month. Here we are providing the interval as month, and we are shifting to the next month. So it knows that it needs to give the last date of next month. Instead of giving 29, it will give the last date of next month. So this is one interesting feature about DATEADD function. This is how you can use DATEADD function practically. If you want to calculate sales in the current and previous months, it also reports sales in the same month in previous quarter and year. So here we are taking same period last month by specifying interval as month and offset as -1. This will calculate the sales amount for last month. Same period last quarter, we are specifying quarter and -1. Same period last year. So here we are using same period last year directly instead of using DATEADD and specifying year, because both are basically same functionality. So here you can see that the same period last month will give the last month sales for each month, and same period last quarter will give the last quarter sales for the corresponding month. So here for April is the first month in second quarter, so it will get the first month sales in the previous quarter, which is 794248. Similarly, for second month of second quarter, it gives the second month of first quarter. So you can see the pattern. For same period last year, it gives the details for the same month last year. So for January 2008, it gives the corresponding sales for January 2007. So this is how you can use DATEADD function in order to do some complex calculations. Now let's see challenge for day 9. You have a sales orders table with the following columns: order date and sales. You need to write a DAX measure to calculate the year-to-date sales based on the order date. Create another measure to calculate the sales for the same period last year. So the first measure is straightforward. You can directly use TOTALYTD in order to calculate the year-to-date sales. So we can use TOTALYTD, sum of sales, and specify the date. The another measure we need to create is for calculating sales for the same period last year. So we can use same period last year in order to calculate the sum of sales and specify the date. TOTALYTD accumulates sales from the start of the year to the selected date, and same period last year shifts the date range to the previous year. So I hope you understood some of the most important time intelligence functions today, and it's a good idea to implement these functions by taking some examples so that you understand how to use these functions in some complex cases. I hope you found this video useful. If it did, please like this video and subscribe to this channel for more videos like this. Thank you for watching, and I will see you in the next one.